Welcome to this lesson video. Today we'll be looking at Cramers rule 3x3 system. Let us start. We have these three linear equations. The first one, the second one, and the third one. Remember, we are solving for x variable, y, and z. Now remember from the first examples, when we look at a 2x2 matrix, the first step, we need to write this in a matrix form. Then from there, we start by calculating the determinant, and then from there we solve for x followed by y and z. Now our matrix, it will be like this. Our entries is 4, 2 and 6. We have 2, 1 and 3, -6, 3 and -3. This will be our matrix. It doesn't consist of the results. When I say the results, I'm referring to these numbers. We only take the coefficient of x, y, and z. Suppose this is matrix A. Now we need to calculate the determinant. Determinant of matrix A is equals to, now a 3x3 matrix, what we need to do, we need to extend this matrix with the first two columns. So we have 4, 2, 6, 2, 1, 3. It's an extension. There is a lesson video whereby we look at how to calculate the determinant using this method. After extending this, we are going to look at these diagonals. That is our first diagonal, our second, our third diagonal. Then from here, we look at this diagonal, this one, and also this one. So we start by multiplying the first diagonal. We have 4 multiplied by 1 multiplied by -3 plus the second diagonal is 2 multiplied by 3 multiplied by 6 plus the last diagonal is -6 multiplied by 2 multiplied by 3. Then for the second diagonals, we minus. So the first diagonals minus the second diagonals. Now let me just continue from here. So it's negative 6 multiplied by 1 multiplied by -6 plus 3 multiplied by 3 multiplied by 4 plus the last diagonal. This is the first, second, and the last one. The last one we have negative 3, 2, and 2. Let us simplify. So 4 multiplied by 1 multiplied by negative 3, we have negative 12. 2 multiplied by 3 multiplied by 6, we have positive 36. Negative 6 multiplied by 2 multiplied by 3, negative 36, minus our second diagonals. Six multiplied by 1 is 6, multiplied by negative 6, the answer will be negative 36. Three multiplied by 3 is 9, multiplied by 4, the answer is positive 36. Then the last one, we have negative 3 multiplied by 2, it's negative 6, multiplied by 2, it should give us negative 12. Negative 12. Negative 12 plus 36 minus 36, negative and negative is positive 36. This and this, it's negative 36. This and this is positive 12. Now you can see that we have negative, actually, let me do this. This and this will cancel each other. This and this will result into 0. This and this will also result into 0. Now the moment you try to calculate the determinant, you find that the determinant is 0. We cannot use Cramers rule when it comes to solving this particular linear systems. Your determinant shouldn't be 0. So if the determinant is 0, this method won't work. We can use other methods. Let us look at the next example. But this is the procedure on how to calculate the determinant. Our example number 2. Remember the matrix form. So we have 2, 4, 3. We have 3, 1, and negative 2. We have negative 1, negative 3, and 5. Then this is the determinant. We expand 2, 4, 3, 3, 1, negative 2. And then from here we start with the first row. Two multiplied by 1 multiplied by 5 plus it's 2 multiplied by 1 and 5. Then from here we have this, this, and this, so it's 3 multiplied by negative 3 multiplied by 3 plus negative 1, 4 and negative 2. So you have negative 1 multiplied by 4 multiplied by negative 2 minus we have 3 multiplied by 1 multiplied by negative 1. So we have 3 multiplied by 1 multiplied by negative 1 plus negative 2 multiplied by negative 3 multiplied by 2. So we have negative 2 multiplied by negative 3 multiplied by 2 plus we have 5 multiplied by 4 multiplied by 3. So it's 5 multiplied by 4 multiplied by 3. The determinant. So 2 multiplied by 1 multiplied by 5, it's 10. Plus 3 multiplied by negative 3 multiplied by 3, it's negative 27. Plus negative 1 multiplied by 4 multiplied by negative 2, it's positive 8. Minus, we are looking at the our second diagonals. 3 multiplied by 1 multiplied by negative 1, it's negative 3 plus, let me put a square bracket here, plus negative 2 multiplied by negative 3 multiplied by 2, we have 12 plus 5 multiplied by 4 multiplied by 3, we have 60. Actually, there's no need for a square bracket. You can simply put this. So we have 10 minus 27 plus 8 . This multiplied by this is positive 3. Actually, before I remove the bracket, let me simplify inside the brackets. So we have negative inside the bracket, negative 3 plus 12 plus 60, we have positive 69. Okay, so 10 minus 27 plus 8, we have negative 9. Then removing the bracket, we have negative 69. Then our determinant will be negative 78. You can see that our determinant, it's not 0. So in this case, we can continue applying Cramers' rule. Basically, Cramers' rule, we just calculate the determinant throughout. Now, to solve for x, what we need to do, it will be dx, determinant using the x values. Actually, is the determinant, whereby the column of x values we substitute by our results over the determinant we just calculated. So what we need to do, now remember our linear systems is 2x plus 3y minus z is equals to 1, and then we have 4x plus y minus 3z is equals to 11, and then we have 3x minus 2y plus 5z is equals to 21. Instead of substituting on the first column, instead of substituting these entries, we are going to replace these entries with these ones. So instead of 2, 4, 3, we are going to say 1, 11, 21. And then we rewrite the other entries. So it's -1, -3, and 5. Then from there, let me just create a space here. From there, as usual, we extend 1, 1, 11, 21, 3, 1, and -2. As usual, like the first procedure, we need to do this, and this. And then from there, we do this, and this. So we have 1 multiplied by 1 multiplied by 5 plus 3 multiplied by -3 multiplied by 21 plus -1 multiplied by 11 multiplied by -2 minus our second diagonals. We have 21 multiplied by 1 multiplied by -1 plus -2 multiplied by -3 multiplied by 1 plus the last one will be 5 multiplied by 11 multiplied by 3 multiplied by 3. Then from here we can simplify. So we have 1 multiplied by 1 multiplied by 1, we have 5. -2 multiplied by -3 multiplied by 1 is 3 multiplied by -3 multiplied by +21. Our answer will be -189. And then we have -1 multiplied by 11 multiplied by 2. Our answer will be +21. Minus our second diagonals. 21 multiplied by 1 multiplied by -1 is -21. Negative 2 multiplied by negative 3 multiplied by 1. Our answer will give us positive 6. 5 multiplied by 11 multiplied by 3, it's positive 165. 189 plus 21, and then minus, inside the bracket we are going to have negative 21 plus 6 plus 169. It will give us 150. And then we have this 5 minus 189 plus 21. The answer should give us negative 162 minus 150. And then the answer will give us negative 312. So this is the determinant when we replace the x values with our results. So from there we can conclude that our dx is equals to this. We need to continue to find our dy. dy is equals to the matrix 2, 4, 3. The column of y entries we substitute by our results. So it's 1, 11, 21, and then we simply replace the rest. Then as usual we are going to expand or extend 2, 1, 4, 11, 3 and 21. Remember the first diagonals. So we have 2, 11 and 5, our first diagonals, plus 1, negative 3 and 3, second diagonals, plus negative 1, 4 and 21. Our last diagonals is this one. Minus, we have this, which is 3, 11 and negative 1, plus we have this 21, negative 3, 2, then the last one is this one. We have 5, 4 and 1. From here we solve. Two multiplied by 11 multiplied by 5, the answer is 110. 1 multiplied by negative 3 multiplied by 3, it's a negative 9. Negative 1 multiplied by 4 multiplied by 21, the answer is negative 84. Minus 3 multiplied by 11 multiplied by negative 1, the answer is negative 33. 21 multiplied by negative 3 multiplied by 2, the answer will give us negative 126. Plus 5 multiplied by 4 multiplied by 1, it's 20. 110 minus 9 minus 84. The answer will give us 17. Negative 33 minus 112 plus 20. The answer is negative 139. Then from here we have 17 plus 139, and then we have 156. This is dy. Let us continue solving for dz. So dz is equals to the entries of z we substitute by the results. So we have 1, 11 and 21. Then we need to extend 2, 3, 4, 1, 3, negative 2. Then we start dz. First 1, 2, 1 and 21 plus the second one. We have 3, 11 and 3. The last one 1, 4 and negative 2 minus second diagonals. We have this 3, 1, 1 plus this negative 2, 11 and 2 plus, then the last one is this one 21, 4 and 3. We solve. dz is equals to 2 multiplied by 1 multiplied by 21. The answer is 42 plus 3 multiplied by 11 multiplied by 3. The answer is 99. 1 multiplied by 4 multiplied by negative 2. It's negative 8 minus 3 multiplied by 1 multiplied by 1. It's simply 3 plus, actually let us do this, 2 negative 2 multiplied by 11 multiplied by 2. The answer is negative 44. Then the last one we have 21 multiplied by 4 multiplied by 3. Our answer should give us 252. Then from here 42 plus 99 minus 8. The answer is 1. It's 133. The answer is 133 minus, inside the bracket we have 3 minus 44 plus 256, 211. Then from here 133 minus 211. The answer should give us negative 78. So this is dz. Now from here, what do we do? Remember, for x it's dx divided by our determinant. For y, it will be dy divided by determinant. For z, it will be z is equals to dz divided by determinant. Then from here, x is equals to our dz is negative, our dx is negative 312 divided by our determinant, it's negative 78. And then our x is equals to 4. That is the first solution. Then for dy, actually for y solution, it's dy divided by dy is equals to, our dy is 156 divided by negative 78. The answer is negative 2, the second solution. For the last solution, z is equals to dz divided by d. So z is equals to dz is negative 78 divided by negative 78. Then our answer is equals to 1. X is equals to 4, y is equals to negative 2, and then z is equals to 1. Now these are the solutions using Cramers rule. It's a 3 by 3 matrix. Let me give you linear systems that you are going to solve. The solutions for this linear systems: x is equals to negative 10, y is equals to negative 79 over 11, z is equals to negative 91 over 11. Just work out using Cramers rule and verify your answers. These are the correct solutions. That's it for this lesson video. This is Baula SJ. Thank you very much.